Alright, so I have some of the most missed questions from part 1 of the 2016 multiple choice practice exam. So the most missed question by the class was number 15. Speed of a runner in miles per hour on a straight trail is modeled by this function, where m is the runner's distance in miles from the start of the trail. What is the maximum speed of the runner from mile 0 to 3? Alright, so first thing I'm going to do is I'm going to get my table of possibilities over here, and I'm going to put a 0 and a 3 in just so that I'm sure I check those endpoints as we go. Alright, next thing, when we want to optimize, we're going to take the first derivative. What I might do to make this a little easier to take the derivative is I might send that 1/10 in. So I've got negative 1/5 m cubed plus 9/10 m squared minus, let's see, that would be 12/10 or 6/5 m plus 7. Now when I take the derivative f prime of m, I get a negative 3/5 m squared plus a 9/5 m minus a 6/5. Alright, so first thing I notice with this is I can factor a 3/5 out of everything. So I'm going to take a negative 3/5 out. That leaves me with an m squared minus 3 m plus 2. That factors very nicely for us. So we have negative 3/5 times m minus 2 times m minus 1, which means that critical numbers, if I set that equal to 0, are going to be m equals 2 and m equals 1. Alright, so that gives me two values that I'm going to toss in over here on my table of values to check. And again, these are m values, and we're going to find the value of f of m. So now what I'm going to need to do is I'm going to need to plug each of these back into f of m. So let's take a second and plug those in. So plugging those values in, we get f of m at 7 at 0, 6.5 at 1, 6 3/5 at 2, and 6 1/10 at 3. That means that our correct answer for the maximum speed is going to be 7. Alright, this occurs at time 0, but the maximum speed is 7, and it would be in miles per hour. Hope that helps. Thank you.